We can't leave out trigonometry. Here we're looking at f of x is equal to the sine squared of x. Clearly the domain is all real numbers. We have x-intercepts that occur at multiples of pi. So n pi, and at all of those, the y value is 0, and we'll just say that n is an integer. And I guess we can throw in that this is an even function. And since it's sine squared, I'll go ahead and throw in that the range is 0 to 1. It would be negative 1 to 1 for sine, but that squared throws everything off, right? All right. F prime of x is equal to, don't forget the chain rule here, 2 times the sine of x times the cosine of x. F prime of x is equal to 0 implies that x is equal to n pi, that's what zeroes out the cosine function, or 2n plus 1 pi over 2, that zeroes out the cosine function, and n is an integer. We're of course not going to look at the x-axis for all of these numbers, but suppose we consider from negative pi to pi, and then also 0. Oh, negative pi over 2 and pi over 2. For what we're about to do, I think a really good approach is to use the unit circle. And labeling negative and positive angles on the unit circle, we have negative pi, which is at this, it's coterminal with pi. Negative pi over 2, which is coterminal with 3 pi over 2, 0, pi over 2, and then pi. And this will make it easy to say that between negative pi and negative pi over 2, we're in the third quadrant, and so f prime is going to be negative. Why? Because it's the product of sine and cosine. I said negative, and I mean positive, don't I? Because it's the product of sine and cosine, and in the third quadrant, they're both negative. Between negative pi over 2 and 0, now the signs are opposite, so negative there. Between 0 and pi over 2, positive. Between pi over 2 and pi, opposite signs for sine and cosine, so the product is going to be negative, and I think that's going to be good enough for us. Let's use this information to say that the function is increasing on, and we'll just identify a couple of the intervals, negative pi to negative pi over 2, together with 0 to pi over 2, and decreasing on negative pi over 2 to 0, together with pi over 2 to pi. And like you can see that positive to negative here around negative pi over 2, so we have a local maximum, and then negative to positive around 0, so we have a local minimum. But we already know what the local max and local min are. We'll just write it down. Local maximum is 1. It happens a bunch of times. Local minimum is 0. It happens a bunch of times. For f double prime, I'm going to rewrite f prime. And I'm not just going to rewrite it. 2 times the sine of x times the cosine of x is a double angle identity, or it's involved in a double angle identity. It's the same thing as the sine of 2x. You can use the product rule on this and deal with the result, or not. So f double prime of x, I'm just using the chain rule, is going to be 2 times the cosine of 2x. F double prime of x is equal to 0 implies that 2x is equal to, let's stick in this interval here. Now we'll go a little bit outside it, my bad. For the cosine function to be 0, the angle, or the argument, should be like negative 3 pi over 2, negative pi over 2, pi over 2, 3 pi over 2, those kinds of things, right? So if 2x is those numbers, then x is equal to negative 3 pi over 4, negative pi over 4, pi over 4, 3 pi over 4, and numbers like those. Now I'm going to put those on a number line, and then I'm going to bring in the unit circle again so that we have it in front of us. Now work with me here. I need a number to the left of negative 3 pi over 4. So I'm going to look at the unit circle here, and negative 3 pi over 4 is down here in the third quadrant. I don't want to go too far negative, so I'm going to use negative 5 pi over 6 for a number that's to the left of negative 3 pi over 4. Between negative 3 pi over 4 and negative pi over 4 exists negative pi over 2. So I'm going to use that one. Between negative pi over 4 and pi over 4, we have 0, so I'll use 0. And then again, between pi over 4 and 3 pi over 4, we have pi over 2. And to the right of 3 pi over 4, which is over here in the second quadrant, I don't want to go too far, so I'm going to use 5 pi over 6. Now keep hanging on. Remember, we're looking at f double prime is 2 times the cosine of 2x. So before I evaluate f double prime, I've got to double all of these angles, right, to figure out what's going on. Negative 5 pi over 6 is way over here, just underneath the negative x-axis. And if I double that, then I get negative 5 pi over 3, which lands in the first quadrant. And we know that the cosine is positive in the first quadrant. You see how this is working? Let's do it again. Negative pi over 2, double it, I get negative pi. The cosine of negative pi is negative 1, so negative there. Of course, the cosine of 0 is 1, so positive there. Pi over 2, double it, we get pi. We're back there at negative 1. And then if it was rough here with negative 5 pi over 6, let's see if this helps at all. 5 pi over 6 is over here in the second quadrant. If I double that, I get 5 pi over 3, which lands me in the fourth quadrant, and the cosine is positive in the fourth quadrant. So I'm just going to write down a couple intervals for each of concave up and concave down. We're concave up on the interval from negative pi over 4 to pi over 4, and if you see the pattern, then you're going to know that this is going to be from 3 pi over 4 to 5 pi over 4, and I'm going to leave it at that. Concave down, negative 3 pi over 4 to negative pi over 4, together with, say, pi over 4 to 3 pi over 4. As far as inflection points, if you're noting the pattern here, we have odd multiples of pi over 4. So I'm going to say 2n plus 1 pi over 4 comma, oh geez, do we have to figure out the y coordinates for all of these? Yeah, but it's really easy. Because at odd multiples of pi over 4, the sine function is 1 over the square root of 2, either positive or negative, but this is sine squared. So these are all going to have y coordinates of the square of 1 over the square root of 2. So 1/2. Now we'll put this together in a graph. We said we had x-intercepts at multiples of pi, so negative pi, 0, and pi. Local maximum of 1 at odd multiples of pi over 2. And then we have at odd multiples of pi over 4 inflection points. We can also look back up here and see that we are from negative pi to pi over 2, or from negative pi to negative pi over 2, increasing and then decreasing to 0, and so on. I need to be increasing, decreasing, increasing, decreasing, and then I need to be concave up, concave down, concave up, concave down. So I'm going to start here at negative pi over 2, go concave down, and then switch to concave up there. And then I'll keep trying to do that. Concave down here, switch to concave up. Cleaned that up just a little bit, and then concave up to concave down, and then concave down, whoops, to concave up. Made that look a little better too. Let me label the y-axis with a 1, and that'll do it.